Hello everyone, my name is Harnit, Assistant Professor in Ajay Kumar Garg Engineering College. Today the topic of discussion is preposition and predicate logic. We will be doing this topic in two parts. In this video we will be studying the initial basic parts of the proposition and predicate logic. Introduction to logic. First of all, we should know what is logic. What do you mean by logic? According to the dictionary, a systematic use of symbolic techniques and mathematical techniques to determine the forms of valid deductive argument. Thus, logic is a common language by which we can demonstrate the validity of our reasoning. Right? Like we are given one statement. Whether it is valid or not, we will check it with the help of some techniques in this. With logical techniques, with symbolic techniques we will use, and we will check whether the statement given is valid or not. Now see, there are certain propositions. Proposition is a declarative statement that we are talking about, for which we have to check whether it is true or false, whether it is valid or invalid. Right? Proposition is a declarative statement that is either true or false, but not both. A thing can be a true or false, but it cannot be both at that same time. Right? Now, let's see. Lucknow is the capital of Uttar Pradesh. We know it is a true statement, so it is true. Delhi is the capital of Gujarat. It is a false statement. 9 is less than 4, false. X plus y is greater than 0. For x greater than 0 and y greater than 0, then it is a true statement. Right? It may or may be type of cases are not possible here. Right? Proposition logics is a branch of logic dealing with reasoning about propositions. Let P and Q be the proposition that P symbolizes all math students wear glasses. We have to represent the statements like propositions like this. Then second is all EE students know how to wear a plug. These are the things. Just with symbolic techniques we will check whether it is valid or not. Right? Now if we have to negate a proposition, let P be a proposition, then the negation of proposition P is symbolized with dash P. Right? Now suppose the proposition is Delhi is the capital of India. When we have to negate it, we have to write Delhi is not the capital of India. Not will be used to negate the particular statement. Right? Now like Q. Q is 2 plus 5 is equal to 7. This is a true statement. Negation 2 plus y is not equal to 7, which is false. Now these are the symbols we are using, and this is the precedence of the symbols. Right? When we are given a collection of symbols, first we are to solve that equation with the using this precedence. Right? Like first of all, we will see what is given in the bracket. Then is there any negation sign in that? Then AND operator, OR operator, then exclusive OR, then implications and double implications. Right? This is the precedence in which our statements will be solved. Now, logic and bit operations. A bit is a binary digit symbolized with 0 and 1. 0 means false and 1 means true. Bits are usually used to represent the truth values. By convention, 0 represents false and 1 represents true. Bit operations corresponds to the logical operators replacing false by 0 and true by 1. We can use 0 or 1 or true or false. Now let's understand the various symbols in logic. We are working on two literals P and Q. The values that P and Q can have are 0, 0, 1, 1, 0, 1, 0, 1. Right? Now, what is the negation of P? We will just change the bit value. If it is 0, we will make it 1. If it is 1, we will make it 0. Right? P and Q means this product of these terms. We will write here. This is 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. Right? P or Q means at least one input should be high. right? Here both the inputs are low, so answer is low. One is high, high. One is high, high. Both are high, 1, right? P exclusive or Q means that both the inputs should be same, right? See here, 0, 0, we are having 0. 1 and 1, we are having 0. Means we should not have both the inputs same. If we are having the same inputs, then the output will be low in this case. And if we are at different inputs, we are having the high output. Sorry. Now P implies Q, which means if P is true, then Q has to be true, right? In this case, we have to see that if P is true, P should be true, then Q should be also true. And if P doesn't happens, then Q can be anything, right? Now in this case, P doesn't happen. 0, 0 means P doesn't happen. P is 0, Q is 0, so output is 1, right? Because output is high. P can be anything. P doesn't happen, so Q can be anything. The output is high here in this case. Now, in the second case, P doesn't happen, but Q happened. It may or may not happen, so it is again, output is high, right? In this case, P happened, but Q didn't happen. But the rule for implication is if P is happening, then Q has to happen. But it is false here, so that's why the output is low in this case. Again, P is happening, Q is also happening, 1, right? Next is P double implies Q. P is dependent on Q and Q is dependent on P, right? If P is happening, Q has to happen, and if Q is happening, P has to happen, right? So in this case, P, both the inputs are same, the output is high. Both are different, so output is low in both of these cases, right? Input is high in both cases, the output is high, right? This is NAND operator, right? NAND is negation of AND. 0 is converted to 1, 0 converted to 1, 0 converted to 1, 1 converted to 0, right? Similarly, P OR AND, 0, 1. This is NOR. NOR symbol, this is NAND symbol, right? 0 to 1, 1 to 0, 1 to 0, 0 to 0, right? Sorry for this one. This is the OR. We are just reversing the bits here. We are getting this answer, right? Now you should know what is conjunction and what is disjunction. Given prepositions P and Q, the prepositions P and Q written as P and symbol Q is true when both P and Q are true and false otherwise. It is called conjunction of P and Q. All the terms which are joined with the AND are means they are conjunction, right? Given prepositions for these conjunction terms, both the inputs should be high. That's why both the inputs should be high, then only the output will be high in this case, right? Given the preposition P and Q, then the preposition P or Q denoted by this symbol or symbol is preposition that is false when both P and Q are false. If we see the truth table of both AND and OR, right? In AND case where both the inputs are high, the output is high, and we called it conjunction, right? But in case of this, if the in OR case, in disjunction, if one of the input is high, then the output is high, right? Because here we are taking the sum and here we are taking the product, right? Now, implications, right? When we say P implies Q, written as P is to Q, we mean that preposition which is false when P is true and Q is false, right? And otherwise it is true, right? When P is true and Q is false, only in this case the output is false. Rest in all cases, the output is high. Now see, P implies Q means P is sufficient for Q, means for Q to happen, the only thing should be there is P, right? Q if P. If P is there, then Q has to happen there. Q is necessary for P. If P is happening, the Q has to happen, right? So it is necessary for P. P only if Q, right? P can only be completed only if the Q has happening there. Now, let's take one example. Suppose P is I revised, right? And Q is I passed the exam, right? And if we have to write these things, these types, right, in a sentence form or a proposition form, how we'll be writing? If I revised, then I passed the exam, means if P, then Q, right? If I revised, then I passed the exam. I pass the exam only if I revise. This implies this one, right? Okay. If Q will happen only if P will happen, right? I pass the exam if I revised. Or I revised only if I pass the exam, right? That means this one. EQ is this one, sorry. Right? If I revised only if I passed the exam. Here, Q only if P, right? This one. Or, sorry, P only if Q, right? Or P implies Q, right? If P, then Q. All these are same, right? Now see, what is a tautology, what is a contradiction, and what is a contingency. Tautology means the implication is true, means for all the implications, for all the relations which are given, if we draw a truth table, then the output will have true in all its values. Then it is a tautology. If it has false in that column, all false in that column, then it is a contradiction. If it has mixed false and true false, these are mixed, then it is a contingency, right? Let's read the definition once. A tautology is a proposition that is always true, means in this column all the values will be true here, right? The output one. Contradiction is a proposition that is always false, means here in the output column all the values will be false. Contingency is a proposition that is neither a tautology nor a contradiction, means it is a mixed one. We cannot take decisions in this case, right? It's difficult to analyze such a situation. Propositional logic and logic equivalence, right? If P and Q are propositions, then P is logically equivalent to Q if the truth tables are same, right? If have one implication, suppose there is R is an implication, right? We draw a truth table for it. Then R2 is another implication. We draw a truth table of it also, right? If the output of this and output of this are having the same values for same inputs, then this is called an equivalent relation, right? Equivalent, logical equivalence, right? Now, P is equivalent to Q is denoted by this symbol, 3 lines, which symbolizes that equivalence, logical equivalence, right? P and Q are logically equivalent if their biconditional is a tautology. But biconditional means both are dependent on each other, right? And if we See, it is a tautology if this implication and this implication, right, becomes, we take the double implication between them and we draw a truth table and we get a tautology, means all the output column has T in that column, then that means this is a logically equivalent. These two implications are logically equivalent, right? Now there are certain properties in this. First is identity, right? If there is any input, if we AND with T, it is equivalent to P. Whatever value P will take, the answer will be that only. If it is 0 or if it is false, then false and true will be false. If it is true, then true and true is true, right? Similarly in OR, whatever is this value is P. Because with false, if we are ORing with false, then the other thing which the other input is, that is the output. If P is false, false or false, it is false. If P is true, then true or false is true. Because in OR case, at least one input should be high, therefore true. What is domination now, right? Now, it is the reverse of this. P or T will always be true, because in OR, one input should be true, which is given here. Whatever the value of this is, it will remain true always. And if one input is false, everything is false in AND, right? So this can be anything. If it is false, it will be false every time, right? Idempotence, if P or P is always P, right? Either it is P is 0, then 0 or 0 is also 0. Either P is 1 or 1 is 1, right? Now double negation, we can check this also, sorry. P and P, 0 and 0 is 0, 1 and 1 is 1. Whatever we are taking the values in P, the output is that only, right? Double negation, negation of negation is always the element itself. We know this with. Now the commutative law, if we are writing this P or Q is equivalent to Q or P, right? We can check this with the help of truth table if you want, but we know that OR and AND are commutative in nature. Similarly, AND P and Q is equivalent to Q and P. Associative, P or Q or R is equivalent to P or Q and R or R, right? This is a type of addition, right? We know, because in OR we are adding the terms, and addition is always associative. Similarly, multiplication is also associative, right? So you can even check this with the help of a truth table, right? Distributive, this is OR, this is AND, OR and OR means plus and multiplication. We know that these are again distributive. This term is also distributive, right? If we interchange OR and AND, they are again distributive. You can check it with the help of truth table. Draw the truth table for the same. For the left hand side, you can make a truth table. For right hand side, you can make the truth table. Then you can compare the output values, right? De Morgan's law, when there is a negation symbol outside, then all the things are changed. It is negated, I mean. If it is P, then it is converted to negation of P. If it is AND, it will be converted to OR. It is Q, it will be converted to minus Q, right? Negation of Q. Similarly, if there is an OR statement, then it will be converted to AND statement. If P is converted to negation of P, Q is converted to negation of Q, right? Now, excluded middle, right? P or negation of P will always be equal to true. If P is 0, then this is 1. If P is 1, then this is 0. Right? At least one input is 1. So that's why it is always true. This is the OR symbol. And in OR, we just add the terms. Uniqueness means this is AND, we are taking the product in this, right? If this is 1, this is 0. If this is 0, this is 1. That means both the inputs are not same, or one is high and one is low. So that's why it is always false, right? For a product time, both the inputs should be high for a high output. A useful logical equivalence is P implies Q, right? For P implies Q, we can write that negation of P or Q. Sometimes there are questions where we have to solve this implication, right? We can convert this implication into this and we can solve the identities in that. Now, propositional logic. Use known logical equivalences to prove that two propositions are logically equivalent. Now we have to prove that they are logically equivalent, right? Negation of P is equivalent to negation of P is equivalent to P, right? And when we open this bracket, we get this, right? Now we have proved that it is equivalent to this. Now we can also do like this. First open the bracket of this. Negation of P is P. This AND symbol will come OR. This symbol will become, with De Morgan's law, we can prove this. We can directly apply. Sometimes if it is a little complex entity, then you can always use truth table for that. These are the equivalence formulas. These are some questions which are true in logic. You can use any of these identities and you can prove these identities with the help of truth table, right? And you can draw the truth table for any. You will find out that this left hand side is always equal to right hand side, right? Now, 3 close relatives of conditional statements. Let the conditional statement is P implies Q, right? There is some converse of this particular statement is, the converse of a given conditional statement is defined by interchanging the antecedent and consequent. That is, the converse of P implies Q is Q implies P, right? P implies Q ka converse is Q implies P. And what is the inverse? The inverse of a given condition statement is defined by the negation of the original antecedent and consequent both. In inverse, we just have to put a minus sign before it, right? It will become the inverse. P implies Q. Inverse will be minus P implies minus Q. Contrapositive. Contrapositive of a given condition statement is defined by antecedent is the negation of the consequent and consequent is the negation of the original antecedent. Contrapositive of P implies Q is minus Q implies minus P. Yes, contrapositive is P implies Q, then contrapositive is minus Q implies minus P. Yes. Thank you very much.